Well, good morning, good afternoon, good evening, and specifically good night. And we'll get to why that is shortly to everyone, wherever you may be across the world. Thanks again so much for joining us live here for Serverless Office Hours. We are streaming on the AWS Twitch channel, on YouTube Serverless Land, and also via LinkedIn Live. I'm Julian Wood. I'm a developer advocate for serverless here at AWS. And I'm joined today by two super duper folks who I've been waiting for ages to speak to. First of all, André. André is a solutions architect based in Zurich. André, welcome to Serverless Office Hours.
Welcome. Thank you for having me.
Absolutely. So tell us, what is your journey to AWS and serverless and a bit of chaos?
Well, my journey in AWS started, I think, now approximately 1.5 years ago when I started here in Zurich. I'm based here in Switzerland as a generalist solution architect for independent software vendors, so essentially companies that write software themselves. And a half a year ago, I actually joined the serverless community within AWS, where we actually deal with certain topics and help our customers on serverless topics, Lambda, step functions, all the services that are covered in there. And also as part of that graduation process in there, I try to find something which really interests me and actually try to also submit something to the serverless days here in Zurich. And we got submitted for the serverless chaos engineering topic there. And I think that's also where we met, right?
Yeah, that is. Yeah, we were doing chaos in Zurich.
And during that, I also reached out to Kensuke. So that's through that engagement, I actually got to know both of you. So that's really my story right now for service engineering and also the serverless chaos part.
Excellent. Well, great to have you. Yeah, and when I started the stream today and saying good night, well, Kensuke Shimokawa, Kensuke, it is just after 3 o'clock in the morning in Tokyo. You are crazy, and that is high regards. And thanks so much for joining us.
Yeah.
3 o'clock in the morning. Wow, how are you doing? We'll try and keep you awake.
Yeah. Welcome. Yeah, actually, chaos is going in my brain right now. So it's 3 a.m. in the morning. So my name is Kensuke Shimokawa. I am a server specialist based in Tokyo. I've been like 5 years in AWS, and so I love servers. It's like full management manner and distributed manner. So I love those things, but so we need chaos engineering. For the servers because it's distributed and who manage it. So somehow we need to way to discover how to inject chaos into serverless environment. So today I'm so happy. I'm so honored to introduce serverless chaos engineering. Thanks.
Excellent. Well, that is so good that we've got the right people on to talk about this. Well, thank you, Kensuke. We'll be back, shortly, just talking about that. I'm just going to talk about the last week of serverless, but remember, we are live here on Serverless Office Hours. So send us your questions, send us your comments. You can see we globally spanned today. We've actually got no one from America. So if you're on the American side, let us know you're there so we can make sure we're fully covering the globe. But yeah, just looking back over the past week of serverless, the last stream on the 31st of October, Carl and Paris were all about visually building AWS applications. This is a new release from AWS Application Composer, which is a visual canvas to put together applications and be able to export them as infrastructure as code. I was actually blown away how simple it was to use, really great integration, specifically with things like RDS and with VPCs, all those kind of things that it's a lot of cloud formation to wrangle. And so this really makes it easier. And of course, also with the IAM permission. So yeah, have a look at that. It's on our YouTube Serverless Land page, along with all other previous Serverless Office Hours streams. In terms of what's new, well, we're sort of in the pre-event phase, potentially. I don't know whether that officially or unofficially starts. So some sort of things are being released beforehand. Just the second one down, talking about Lambda, faster polling scale-up rates for SQS. So if you're consuming messages from SQS with Lambda, which is very, very common, Lambda's got your back and is going to be able to poll up much quicker as well. Interestingly, code build at the top now supports Lambda as compute. So if you're able to do your builds using Lambda functions, that's got really fast scale-up as well. So able to do that. There are a few caveats. I don't think it works with VPCs and things like that, but still could be a super useful way that you're able to do some of your builds. EventBridge Pipes also just has a console integration. So if you're using Kinesis data streams or SQS, you've now got the possibility within their consoles to jump directly to EventBridge Pipes. And then also another one, Lambda, fourth one down, is IPv6. So this is outbound connectivity in a VPC. So if you are thinking of transitioning over or have a project to transition over to IPv6, Lambda has got your back as well. In terms of some blog posts, Anton and Taran have put together a blog post about SQS with some nice graphs, which just clearly show how much quicker SQS can scale up. Orchestrating dependent file uploads with step functions by Nelson and Jevon. Yeah, really cool one. If you've got two different files that need to be uploaded and you've got to wait for one to upload before the other because you need to do some coordination, they've got a really good architectural pattern to be able to use step functions for that. And just the third one down, Ben on my team has put together the In Case You Missed It. So that's everything to do with serverless in Q3 2023. It's actually astounding how many things have been going out. Those are from blog posts to videos to releases to features to a whole bunch of stuff, information about our EDA day as well. So yeah, quick one-stop shop to go and have a look at that on the AWS Compute blog. AWS reInvent is fast approaching. I know many thousands of people within AWS are mad scrambling to put together the best possible conference for everybody. Kensuke, I know you're going to be there, so yeah. It's going to be cool. We've already made lunch plans, so we're going to have to meet up, and yeah, we'd love you to join us. So yeah, reinvent.awsevents.com. I'm really stumbling over that and haven't even got to Vegas yet. Yeah, there are still tickets available. We'd absolutely love to see you. From all the work that's been going on internally, I know there's so many sessions, so many different ways that you can learn things at reInvent, and so I think it would be great. I would certainly attend, even if I wasn't working at AWS. If you're wanting general information on serverless, our serverlessland.com learn page has been updated recently. There are a whole bunch of new guides. There's a new guide that went up this week as well for using crossplane with EKS. So if you're deploying EventBridge you're doing some EventBridge kind of stuff, you can use crossplane via EKS to deploy those. That's a new guide that's come up just this week. And yeah, loads of other guides, workshops on event-driven architectures, all the different services. Yeah, huge resource of information. But this week, something happened over there. Something disappeared. But this week, as we've been mentioned, we're all about bringing chaos into serverless. And obviously, that is a slightly tongue-in-cheek title, but not really. Yeah, where do we start with chaos into serverless? That sounds partly scary, and not just because it's early in the morning for some of us.
Well, I guess I think it's a good actually approach to start with the high-level concepts of chaos engineering and have actually look at what it actually means. And there's also quite of a misconception when it comes to chaos engineering overall. I think also you advertised today's event if you want to learn how to purposefully break stuff within your production environments. I mean, that's not really the point, right? It's actually you want to build confidence in the robustness of the systems, but also building confidence in your own capabilities to build such systems. Right? That's really important. So I think also if you want to bring up I think we have some slides here to go as well. Like the formal definition for chaos engineering given by the principles of chaos engineering, which is kind of like this governing body dealing with all the questions and definitions about chaos engineering, defines it as the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. It's a bit of a mouthful, but I mean, in essence, it's really about experimenting in order to build confidence. And of course, you're introducing chaos and you're introducing faults, but it's not meant to break the environment, right? You want to get some insights and you want to find some blind spots and really uncover unknown unknowns. So that's really the point and the gist of running chaos experiments within your production environments.
Yeah. I love the expression turbulent conditions in production. I've never actually heard it experienced that way. I think that is lovely. That is great. I want to use that again.
Yeah, I have one question. Why it's important to have chaos engineering within production environment rather than the development or staging environment?
Well, you want to simulate the real conditions, right? So you want to actually have a system that behaves as in production. If you want to do it in testing, that's part of the steps involved, right? You don't start in production, right? That's also something which we really need to point out here, right? That's really something which is not something that you should do, right? So really out of the gate, don't start in production, but the end goal would be to actually run those experiments within production. So you really have the conditions and the infrastructure and also the system as it is in production, right? So because many things can change from testing to production. If you do it in testing, maybe the load on the system is not the same. You're not using the same infrastructure, not the same usage patterns, right? All of the things that are really important to experiment on are really relevant for production, right? I mean, at least have it in somewhat production-like environments, right? So
Cool.
Yeah, I think the whole misnomer with testing in production fascinates me a bit, because I think some people take it to mean that you only test in production, when it actually means you're able to also test in production. So of course, testing in production doesn't mean the rest of the testing goes away. In fact, that is as important, but testing in production gives you a little bit more confidence that you could also test some of these things in production, which is obviously related to exactly where your workloads are running. These are going to be things like limits and security and throughput and all these kind of things that can bite you when there are the turbulent conditions. So yeah, if you are worried about that term testing in production, yeah, please don't think it means test only in production. It just means, well, you've evolved enough that you can also test in production.
Yeah, and what we also kind of look at is like in our principles of chaos engineering, they talk about the different steps involved, right? So they usually you have a couple of steps that are required or are outlined here, and usually start by defining the steady state of the system, right? So this is really the normal behavior of the system over time. Well, let me just quickly check.
Promise you this isn't deliberate. We're not deliberately doing some chaos engineering on slideshow preparation.
Yeah.
I'll try and reshare again.
Yeah.
But Kensuke, when you work with your customers as well, how sort of advanced are they in this chaos engineering? Is this something that is scary and people are sort of have a lot of trepidation in doing it, or are they sort of coming around and realizing how powerful and important it can be?
So in my customer's case, especially enterprise customer, really, are scared about doing like experiment in production. But to have like more confident within their system, André said that it should be in production environment. Yeah, I agree with that. So I will, sometimes recommend having like a CI/CD process or like kind of automated testing manner. So in the same time, I recommend customer do chaos engineering in production. But it's so hard time to explain how important that is and how get good result in production.
Okay.
Yeah.
Okay. Thanks. Yeah. So André, you were talking about the sort of steady state when we were doing some slide transitions that weren't a steady state at all.
About that. Yeah, I mean that's just the first step, right? So you define the steady state, and it should be something measurable, a measurable output of the system rather than internal attribute. So latency percentiles or responses of your APIs, that's something that you can use. And I think a really good example is actually something that combines measurable output but also customer experience. Like for example, a really good example is Amazon and Netflix. So Amazon uses the number of orders per second, actually for the chaos engineering experiments, and Netflix uses starts per second. So really something where they can see the user experience and degrading, and that is kind of the what good looks like for the system, right? And then they use the steady state to actually formalize a hypothesis, which they want to test for in a controlled and in an experimental group. And this is actually then used in the chaos experiment. And here's really the point I would like to make is that, right, if you know that the hypothesis will not hold, right? So if you inject chaos and you will not be within certain tolerance of that steady state, you shouldn't conduct the experiment, right? Because you're aware of some kind of problem within your environment, so you probably set out to fix it beforehand rather than actually conducting the experiment and verifying that you have a problem.
Oh, so that's an interesting take on it. So you're creating this hypothesis, and you actually want to test something that you're going to stress some part of your system, but you want to make sure it's going to work. You're not actually stressing your system in order to break something that is then going to cause an issue. Is that my sort of understanding, that you create a hypothesis and you go, will we be able to scale up our front end to handle 20,000 concurrent users? And that would be then your chaos experiment to test that as well after you've done whatever architectural stuff in the background to ensure that will happen, rather than just going, well, today let's see if our website can handle 20,000 connections, and you know it won't, and it will fall over.
Yeah, I mean, the hypothesis actually is meant to, or you formalize the hypothesis in such a way that it should withstand those turbulent conditions, right? And you just need to also define what it means to withstand it, right? And that's kind of the steady state. And then you inject the chaos and see, okay, can it withstand those turbulent conditions that you inject with the chaos experiments? And then you also need to find, okay, what is actually, what does meaningful tolerance mean as well, right? So it can also be that there's some perturbation, and you're looking at the latency percentiles, and that's kind of the hypothesis that you're going to test. Right, and then let's say the biggest part comes to it, right? So you actually inject the chaos, you inject the failures into your system. And this is also where we're probably going to spend most of this talk, right? So this is a lot different in serverless applications than compared to kind of like server-based environments, because we don't have the tools that we used to have. It becomes a bit more tricky. We don't really know, okay, how do we inject chaos? Because you want to actually simulate real-world events here. And given the tools that we previously had, like most notably the Chaos Monkey or the whole Simin army, cannot really be used in serverless applications, because essentially you cannot turn off or disable the underlying infrastructure, because it's abstracted away from you, which is kind of the benefit of using serverless. But in this case, it's kind of also detrimental to your chaos experiments. Anything you want to add to that, Kensuke?
Yeah. So somehow we can find a way to inject failure into the production environment. So sometimes it causes some kind of errors, like maybe with a network system, or maybe like hardware, malfunction with hardware layer. But in terms of serverless, we don't see like actual network traffic, so it's so managed, full managed, and also we cannot log in with like SSH into Lambda function itself. So I'm so curious about how to inject failure onto like serverless. Maybe we can talk about this later on.
Yeah, and I mean the rest of it, that is essentially the same if you're running chaos experiments in serverless environments, or let's say server-based environments, right? So it's really important to have enough monitoring and logging data, and observability is key here, right? Because you want to actually then prove or disprove the hypothesis, and for that you need to analyze the results of the experiments. Actually, okay, what did you measure? How did your system behave over time? Did it actually go beyond the defined tolerances for your steady state? That's all the things that you try to answer during that chaos experiment, and it should really give you some insight into your system, right? Not only on the steady state, but also actually what happened, how did it behave? Maybe something that you anticipated didn't occur, right? And something else completely happened, which you didn't think of, right? It's really about finding like blind spots. Also, we often talk about unknown unknowns here in the system, and running chaos experiments helps to uncover that as well. Yeah, and if you then obviously disprove the hypothesis, so you couldn't withstand the turbulent conditions, the next step would then be obviously to fix it, right? So you implement certain fixes, new feature, whatever. So that's kind of closing this loop of chaos engineering, and you define a new hypothesis, or you retest your hypothesis if it was disproved. And that's kind of like this endless loop where you continue to run your chaos experiments within your environment. Yeah. Right, I think now it's actually a good time if we talk about the differences between serverless chaos engineering, or the challenges that come with it, opposed to, like, say, traditional chaos experiments. And do you want to take that part, Kensuke?
Well, also, can you move to next slide, please? Oh no, there's no slide. Okay, so in terms of serverless, we don't see any server within your system, right? So challenge is that you cannot find a server to inject your planned failure, right? So somehow we need to find a way to inject failure with into full managed serverless environment. So this is one kind of this is kind of challenging part of serverless chaos engineering. Okay, so and also there's no mature tool set for injecting chaos into servers, right? So look back to the history of chaos engineering. So there's many tools, mature tools to inject chaos into like server or VM layer, right? Or network layer. But those tools that doesn't fit to the servers. I mean like Lambda function itself too, right? So those tool set as good to inject failure into EC2 or VM where, right? But not work for server as well. So let's talk about how to inject failure into serverless. Yeah.
Shall I go to next slide? Should we go directly to the techniques and we can talk a bit about how do you actually inject chaos? I think that's more interesting to the audience, and because there we have different techniques. Yeah, I think already you mentioned it, Kensuke, that we have different opportunities here, right? But beforehand, I think one thing that is actually important to mention here is just the question of why, right? Because usually when people think about serverless services, there's the notion of having a managed service, and much of the responsibility to make sure that it runs in a fault-tolerant, resilient way is shifted onto AWS when you use, for example, Lambda or step functions, right? So many people have this. You think of it, okay, if I use serverless services, I don't have to care about how to actually run them in a resilient fashion, making sure that I have a disaster recovery strategy in place, because AWS takes care of it. I mean, to a point, that's kind of true, right? Because we abstract a lot of that infrastructure management away from you, and that is actually our job and our responsibility to handle that. But still, there's also quite a big responsibility on the customer to actually make sure that they are using those services in the correct way, right? And also, another really important point that I would like to make is just because you're using managed services doesn't mean that you're immune to outages. Right? And it can also happen for managed services that they become unavailable, right? Lambda has had, even if it's rare and unlikely, the service became unavailable. And if you plan for that, right, and if you anticipate that in the wider sense of your application, then you can actually also then deal with that and implement fallbacks and make sure that you're not dependent on that specific, like say, part of your application and have it as a single point of failure. So that's really important to also understand why we're doing it also for serverless applications. Right?
So in terms of configuration manipulation, so let's say we have like Lambda management console, so we can configure its memory and concurrency limit, right? So maybe we can configure concurrency limit to like amount of zero, so it causes some kind of throttling error onto the serverless function, right? Is that right? You are saying that that is configuration manipulation to cause chaos situation status?
Yes, that's essentially it. I mean, the most intuitive way, you just described it like perfectly. Like if you meddle with the concurrency level of your function on an individual basis, but also you could also do it for the count, which is a bit, I'd say, slower. But if you change the reserved concurrency for your Lambda functions and you set it to a low value, you can essentially throttle the Lambda functions. Yeah, that's something that you can do. You can also use the fault injection simulator, which is our own tool to actually run chaos experiments within AWS environments for that. You can also use, let's say, third-party tooling or open source tooling, such as the Chaos Toolkit for that. And it's really also important to mention here that the chaos experiments should be automated as much as possible, right? So even though if you can actually go into the console, right, and change the reserved concurrency level on a function level manually, and then also change it back like after 10 minutes, that's probably not what you would like to do. So you actually want to have a tool that does this for you, the change, monitors like what happens to the steady state, and also monitors if it goes beyond, let's say, the threshold where you say, okay, now I have to roll back and have a mitigation strategy in place. And both the Chaos Toolkit, which is kind of this open source tool, and our own tool, the Fault Injection Simulator, can do that for you. So you can also configure, for example, certain alarms that if they are triggered, then that will change, will also trigger the rollback. And in this case, would delete the concurrency level entirely or set it back to the previous value.
Cool.
Yeah. The network manipulation, I think that's something which can be done, but you rarely see it in the wild. It would probably include like restricting access to networks by using NACLs or network access controllers, security groups.
Mm-hmm.
For example, you could also limit the bandwidth, things like that. But customers for sure not, but also many other people that actually do that, and we don't have too much examples on that. I think the most interesting and the most, let's say, what people think of when they think about serverless chaos engineering is actually the code manipulation. May actually change the code or parts of your code in order to inject chaos. And there you have, a multitude of possibilities, ranging from rather basic, actually changing the function handler code, going to really advanced stuff, to having actually extensions that run the chaos experiments for you. I think something that we can mention is that there are a couple of libraries that you can use for that. So for example, if you have a Python function, you can use the Chaos Lambda library. That is quite easy to use. You just add a decorator to the function handler, and then it injects the chaos depending on the configuration you also specify.
Hey, André, many of my customers are afraid of manipulating their own code in production, right? So yeah, you're right. Maybe you can, bring some chaos library onto Lambda function itself, then manipulate its code, right? But so, it's production environment, so we don't want to manipulate production code, right? So maybe we need to find a way to cause chaos engineering or chaos status without doing code manipulation, right?
Yeah, that's really something important to note. So if you add those library to your function code, you have to change in the case of the Chaos Lambda for the Python, you have to add the decorator for the functions in question, and that's not something many customers would like to do, and it's also not something that you should do, right? It involves an additional step. And I think what actually circumvents that, for starters, you can use extensions, and I think that's also what both you, Kensuke, and I think is kind of the gold standard to run chaos experiments. But there has been a recent blog post also on how to use the libraries, and I think we can quickly because it's a really interesting approach, and I haven't thought about it actually, how to inject those libraries into your Lambda functions whilst running the experiments. And I just want to quickly mention it because I think it's a really nice blog post. I think you can also then share it later, Julian, right?
Yes, certainly will do. Let me grab it up.
Quickly, because I have actually right. What they detail is this so-called handler replacement approach. It is a blog post also by one of your colleagues, I think Marcia, if I'm not mistaken.
Yeah. So what is the handler replacement approach? Is this part of what the library would do instead of doing a wrapper? Well, a decorator for a Python function. Is this, wrapping the handler in something so you can run your experiments within that?
Well, basically it does what it says, right? It swaps the handler during the experiment. So assume that you have your Python function. In this case, it will be Python. You can do the same for Node.js using the other libraries, or you can also write your own libraries for interpreted runtime interpreted languages. And then you have your function code defined in that Lambda handler, and that is also part of the configuration, right? If you go to your Lambda function, you can actually check where your Lambda handler is stored, in which file, and also what the function name is. And then as part of the experiment, so you can actually use the fault injection simulator to run serverless chaos experiments. Even though they're not natively integrated with Lambda, you have to use so-called system manager documents to run the automation execution.
Okay, yeah.
And there you define what is actually performed during the experiment. So the first step would actually be that you you get the configuration from the Lambda service about the function in question, and you retrieve the information about the function handler, so the function file and the function name. And you store that in the parameter store alongside the configuration for the experiment. So you're saying, okay, I want to run an experiment with certain delay introduced and the amount of milliseconds also injected into it. So that's kind of a good example what you can do with those libraries. And you store that in the parameter store. And as a next step, then you change the configuration of the Lambda function. You add a Lambda layer. So this is actually a Lambda layer that you provisioned and host in your own AWS environment. And you tell the function to add that to its environment. And then you also change the configuration of the handler. Now it doesn't point to the original handler, so this Lambda handler. It now points to the layer handler that you defined in that Lambda layer. And it's just a file where you define, like you would with the Lambda handler, you define this so-called layer handler. And now once you actually invoke the function, it will call the layer handler. And upon first invocation, what it does, it retrieves the information from the parameter store about the original function handler, so its file and its function name, and also the configuration for the experiment. And then it uses that to actually retrieve the file from the execution environment and use that to actually then also load it as a module and then call it in this new layer handler with the injected chaos into it. So it's really something I haven't thought about this. Really, it was surprising to me. It's a really interesting approach, and I just wanted to mention it. And I also we'll share the blog post, so credit where credit is due. But really, that shows, okay, for serverless chaos experiments, you need to think outside of the box, right? You don't, at least at the moment, you don't have the set of tools that allow you to easily run those experiments. Right? In an ideal world, you would say, okay, I want to just inject whatever chaos into my Lambda functions and you use the fault injection simulator, which unfortunately it is not the case. So you have to write the document and then it does the different steps, which kind of seem a bit cumbersome. But yeah, it's really something really cool and really thinking outside of the box.
Yeah, André, this is so interesting. So, so cool, right? But still, I find the problem within this approach because, user have to, switch Lambda handler entry point from Lambda handler to layer handler, right? They have to switch their entry point. So it's it means they have to change, code,
Configuration, yeah.
the configuration and the code. And also, so it's, so maybe user can find good or mature library for chaos engineering. Like you mentioned Python and Node.js, but for instance, maybe the user want to use like PHP instead of using Python, right? So, so in that case, they have to find PHP good, mature chaos library, right? Or they have to implement their own, right? So maybe we need to find some way, maybe a runtime agnostic approach, right?
Yeah, I think that's also why we save the best for last, right? And I think that you've been sitting on your seat, we're just waiting to actually introduce how we use chaos, how we use Lambda extensions to run chaos experiments. So I think I leave it to you to introduce how we do that. But then again, we have different approaches that you can use there, and maybe you can also say which you would like to highlight, and maybe we don't have time to go into all the different approaches, but I guess there's probably one that is your favorite, and we can talk about that a bit.
Cool. Thank you.
Just tell me which one, and I can go also to the slides to highlight it. Or
okay. So maybe we can move to extension.
should we just briefly recap extensions and execution environments, or is it something that we?
Yeah. So maybe some of listener doesn't know execution environment and Lambda extension. So probably we need explain some tips about Lambda extension. So now this diagram showcase how Lambda environment composed by layer. So we can see red red execution environment and blue execution environment. This is different Lambda environment, right? And within the Lambda execution environment, you can find function A code and function A extension code. And meantime, you can find also function B code, right hand, and extension B code. So this is so isolated environment. But you can find extension code can approach to function A code or function A temp storage or function A network. And look at the right hand, function B extension code can handle function B temp storage or function B network. So maybe extension can manipulate temp storage or network. So extension is like sidecar in terms of container, right? Maybe some of the listener use maybe have some kind of experience about container like ECS or EKS. You can maybe you bring some sidecar to manipulate request or proxy request, right? So within Lambda service, you can do similar manipulation or proxy pattern within Lambda function. So with Lambda extension, you can manipulate, request, and also you can manipulate response. So and you can manipulate random API call. Yeah.
Sorry, I do. This is what you were talking about, right? So this proxy
Yeah.
pattern, and I think you also mentioned it, Julian. One of the blog posts that has been published this week actually details how you actually use this API, this runtime API proxy pattern for other things, right? It doesn't necessarily pertain to chaos engineering. It also can be used to actually increase the security of the Lambda functions and all sort of other things. It's a really good read, and if you really want to understand how the runtime API proxy pattern works, it's a really good place to start there.
Yeah, certainly. I'm just putting a link to the blog post. Yeah, the runtime API proxy is a little shim that goes between the Lambda function and this runtime API. Sorry, I'm pointing at my screen to the runtime API, and it allows you to just grab what's coming in via Lambda and before it gets to your function, and then something after your function's processing it and manipulate that or drop it or do something like that. So yeah, it's a really clever way, and yeah, it's really good blog post by Anton and Sridhar, who have put together this nice reference architecture. So yeah, have a look at that.
Yeah, and it's a really nice way to actually then intercept the calls to and from the runtime API, and actually then inject the chaos. And there you're basically free to do what you would like to do, right? So you can inject chaos, you can just throw error responses back. It's up to you and your imagination to do whatever chaos experiments you think make sense, right? To actually then simulate real-world events. So that's kind of like the gold standard.
So how much sort of for specifically using the runtime API proxy with chaos engineering, sort of how much configuration do you need to do yourself? Or if someone wanted to use this Lambda chaos extension with the runtime API proxy, how does one set that up? Obviously, you've got to add the extension, but then in terms of the configuration and the different kind of tests you can run, do you sort of have some ideas how that would work?
I mean, it depends, right? So I can also show you how it works with the let's say the basic configuration. If you, first of all, why I'm saying it depends, you can write this extension yourself, and then you're really free in how you handle the requests, and then you can also, for every kind of configuration that you would like to actually do and the different experiments that you want to handle, you can write them yourselves. But that's also something not everybody is comfortable in doing. That's also, there is already this chaos extension that you can use. So I think I send you the link, but can I share stuff?
Or send it to me via the chat, and then I can send it, put it on the screen. Is that the link at the bottom there? Chaos extension, yeah.
That is it, yes.
Yeah.
Because I think I can also show you how you would use that, and it's quite easy to use. So I'm just trying to going to share my entire screen to do a little demo.
I'm just grabbing that link. Amazing. Yes, that's a GitHub repo. With excellent. Let me add your screen on. Yeah, André, your screen is available.
Perfect. So now what you can do is you can also use that then in your fault injection simulator experiments. Right? Now here, I try to play around with it, and there are actually two approaches, right? So you can actually have that extension, let's say, added to your execution environment all the time. But there are some drawbacks to that as well, right? So an extension needs to be initialized, so it adds to the cold start behavior of your Lambda function. There's a limit to how many layers you can actually have, so maybe that's probably not the best way to do it. It depends on the use case. So maybe another approach is also that you inject that extension during the experiment, so only Lambda functions that you're actually then testing or experimenting on actually have that chaos experiment. The chaos extension actually added to it. So if we actually have a look at the experiment templates, so that's also something that I think we can share it later on. It needs some review, and then we can send it to the audience. Also, I think on YouTube, we can add that quite easily. But let's see, with default injection simulator, you define the experiment templates, right? And I need to check if I use the correct one. Yes, this is it. Let's have a quick look at all the actions. And again, I mentioned it. If you want to use it for serverless environments, you have to, at least at the moment, write the SSM documents. Yeah, it's probably not the easiest thing to do. It's not difficult, but it takes some time getting used to it and how you define the documents. It wasn't the most pleasant experience, if I'm honest, but eventually you get the hang of it. And I think it's easy also if I show you the document itself, and there you can really see what is actually involved there. So in a nutshell, what you're doing, you're rolling out the changes, or you're injecting the chaos. That was the quick.
It's interesting. I've never actually thought of using SSM documents within Lambda functions to do things. I know it's, I've done it, for lots of other kind of things, but I'm intrigued and interested. I like this approach of using, another service to actually, store and host the code. And then I think, using fault injection simulator sort of as your orchestrator to run these experiments.
Yeah. So what you then define also as an input to the experiment, but you can also then pass it then to the document, is actually the function name, so the function that you would like to experiment on, the layer, that is the layers that are actually also provided by the tool. Like, so this, what I showed you before, the GitHub repo actually offers that you can actually take the layers that they have actually hosted on their environments and their accounts and can actually inject that. I think for production environments, if you run this in your own production environments, don't use layers from other accounts. Deploy it to your own account. You can actually also then fork the repository and deploy it to your own account and use it from there. But you need to specify which layer to use, even if it's in your own accounts or from external accounts. But you need to say, okay, which kind of extension layer that you're going to use. And then the rest is quite easy to understand. So you say, okay, which kind of chaos type that you would like to inject. And depending on the type, then you have to define the latency, the response. That's quite fairly easy and straightforward here. And what happens then is actually that you add the extension and also add the environment variables. So we're going to see that. And then this is kind of like the sleep state, which is the overall duration of the experiment. This is where you gather the data about the experiment, about the steady state, and see how it changes. And you can also then define a CloudWatch alarm, for example. If that is triggered, then you will also roll back. So either you pass the sleep state, so it's kind of the duration of the experiment is over, or the alarm has been triggered, and then you roll back. This is where you then remove the layer and set everything to the previous state. So let's quickly run the experiment. I think it's quite nice to see what happens. Before, it's always good to have a check at the Lambda function, how it looks like, what state it is in. So for this experiment, we're using the demo 3. And this is really a basic Lambda function, which is just the hello world function, and that's the output of it. Right, so that's the Lambda function. And for the sake of it, I kept it quite clear and simple, so we can really see, okay, what it's about. We don't have too many stuff in here. I think important here, also no environment variables. And using the environment variables, we actually then can configure the experiment. So this is where we actually say, okay, this is the type of the chaos experiment that you want to run, either latency or response for this extension. And then you also define the amount of latency in this case, or the specific response that you're passing back to the runtime API. So if we then run the experiment, put this in another tab. This is it. So we're just going to start the experiment. It's pre-populated with default input parameters, so we don't have to deal with that at the moment. Going to start the experiment. It just starts it up, initiates it, and then it runs the automation execution.
So this automation execution is then going to add a Lambda layer onto that Lambda function. Is that the sort of one of the first steps? Going to add some environment variables for configuration, and that configuration is then going to define what you're actually going to test. And what there were two things: there was latency and something else you mentioned.
So you can change the response type and also the response message.
Okay.
So in this case, when we see, I have to check. So if we look at this.
So yeah, no, a whole bunch of environment variables. There we go.
Yeah, and also we can see it takes a bit. We see, okay, we had the layer is actually added to the Lambda function. And then also the configuration, if we go to the environment variables, these are the things that we actually then need to define.
Okay, yeah.
This is something that we need to do in order to have this API proxy pattern actually enabled. I think the blog post goes into great length in actually explaining how to do it. I think we can skip that. But those are the environment variables that you need to define or can define, right? In this case, we're just saying, okay, we want to enable to change the response body, set this to true, rather than having latency enabled. So this is false in this case. Cool. And what hopefully does, live demos are usually something can go wrong. So
just before on the code, this is actually going to amend the response from the Lambda function. This is our test, because we didn't actually run this function before. The previous I can't remember what the previous function code result was. Hello world, was it?
Yes. So if we look at the code,
hello from Lambda. There we go.
It's just hello from Lambda, right?
Okay.
And, if we then actually enable the experiment with that specific chaos type, which is changing the response body, is that we change it to something which we defined before. And this is hello chaos with the status code for 500.
I can imagine this would be a terrible prank to play on somebody to go, my code's not working. It's the simplest Lambda function in the world, and it's not responding what I expect it to be. Somebody would be going nuts hunting at the code going, what is going on? Anyway, my evil genius mind was just playing tricks on me.
I mean, and the other thing is then you can also easily change it here. I mean, if we're going to edit that, now I'm doing something which you shouldn't do because I'm changing it manually and I'm messing with the overall flow of the experiment. Let's say I'm going to change this to true. So we're going to introduce latency, and this is going to be false. And I don't remember. I think it's in seconds, which is an awfully lot. And maybe that is then also showing us some behavior that we're actually testing for, right? So because if you do not set the timeout values correctly, that is something that will then also, you can actually see that using the chaos experiments. Right?
Yeah.
So it takes a long time, right? So,
yeah.
Oh, so this is also a way to simulate if your function is going to time out without actually having to amend your timeout value.
Yeah. So what we see here, it's also we enabled logging, right? Because otherwise, if we don't have logging, that's also important. We saw, okay, we got the response that we expected, but it takes like 10 seconds, or duration was 10.4 seconds, which seems off. But then again, we actually have logging enabled, and we see, okay, we added latency to the Lambda function for 10 seconds. So that's also really important. Otherwise, you don't have visibility into it. And also, if you want to play pranks to your colleagues, that's some way to do it.
Hey, André, can I see the Lambda layer? So you can go the quick console to the layer part. So down. Yeah. So this layer showcases that compatible runtime are Python and Node.js and Java, and any runtime that's accepted by this layer, right? So it means this layer is runtime agnostic. So this is what we wanted, right?
Yeah. So yeah, this is a in a compiled binary. I think is it either Go or Rust? I seem to remember. And so
this case is, I think that library is Rust. Yeah.
In Rust.
And you usually say you should do either Go or Rust. I think there's also an example how you would do it with Python. If you're not familiar with Rust, you can also have a look at that. It really shows you how you actually set up extensions as well. I think that's also the added benefit of using that, because you really get to understand the inner workings of the Lambda service, how the extension and the runtime API work, and how you actually deploy layers, and how you create extensions yourself. That's something which every, like, say, advanced or power Lambda user should know, and it's
definitely. That's a good learning way. Yeah. When I learned a whole chunk about Lambda, writing a lot about extensions and doing custom runtimes and all these kind of things, and you really know at a low level how the Lambda service works. And funny enough, I found it's not that actually complicated, but you just need to go through the process to understand what it's doing, and you actually realize how simple the Lambda API is. Lambda obviously does a lot for you, but the actual Lambda API isn't that complex, which is good to know. So just quickly to wrap up, because we only probably sort of got another minute. So we've got a chaos engineering over here. We've realized some different things we need to test. I'm sorry, there was actually a question earlier which I missed. Stay, Stephen, these are the only three when we were talking about the code and the networking and the configuration. I was going to throw out any other ideas for testing, but I suppose you could test anything. So we worked through that. We've then realized we've got to do some of these experiments, and you could replace the handler, but found that could be a bit error prone and a little bit complex. And so there is this ready to use Lambda extension, which you can use and you can coordinate with the fault injection simulator. The fault injection simulator adds this all automatically to your Lambda function and uses an SSM document to actually do that. And then you have this ready-to-use function, which you can ready-to-use function with an extension added, and you can customize to your heart's content. And we showed a demo here of changing the response payload and also adding some latency. But because it's just a normal extension, which is normal code, you can off you can go and do as much as you want, really.
Well said.
Cool. Anything to add in the last half minute?
I mean, we covered most of the topics that we wanted to cover. I think we're going to share a couple of links that you can test out, and I think it's also for the audience, just try it out and what you feel makes really sense, and also I think also what Kensuke and I are interested in, if you have any other ways how you actually employ serverless chaos engineering in your own applications. Yeah, cool. Do reach out to us. And also, if you have other approaches, we're really interested and keen to know that. So that's really something. Yeah,
what you're doing in your company, let us know. And we'd love to add to the body of knowledge for this as well. We did also have a question from the Chess Warrior, which I just wanted to address quickly. When you reference a Lambda layer from a Lambda function built using Docker, updates to the layer aren't reflected in the Lambda. Way to solve besides redeploying the Lambda. Chess Warrior, if you mean you building a Lambda function using a container image, that is immutable when you create that. So in fact, Lambda layers aren't even supported in container images for Lambda functions. You basically copy the copy the Lambda layer into your function artifact, which is one big chunk, which is a Docker file. So I'm not quite sure if that's answering your question, or you're talking about when you using SAM locally to test and run your Lambda applications, because that also uses Docker. So if you're using a container image, any update to your Lambda function needs to be redeployed. So hopefully that answers your questions really quickly. And just quickly, don't forget reInvent is coming up. Kensuke and I would love to see you there. Serverless patterns, workflows, snippets, repos, lots of code on serverlessland.com to be able to get started with a whole bunch of cool things. And most importantly, thank you very much to André, and thank you very much, Kensuke, for taking us through a journey of chaos engineering. And we appreciate you putting a demo together and your time today. And everybody else, good luck with your experiments. Cool. We'll back same time, same place next week. We're actually going to be talking to Amped. So Amped is a new sort of infrastructure from code tool, being able to just write code, and you're going to be able to then do some cool stuff. So same time, same place next week on Serverless Office Hours. And we appreciate you joining us, and especially Lakshmi Prabhakapulu. You got some notes. Well, I'm glad you were taking notes. Hopefully it's all been useful. Thank you very much. Enjoy